Okay, hello. I'm officially welcoming you all to our second online session of Foundations for Statistics using R. Welcome. Glad that you can make this session, and I want to make sure that it's worthwhile for you. As always, if you have questions, please feel free to use the text chat. I'm going to enable my camera right now just to kind of like say hi and so you guys all can see me. There's like some shadows coming in because it's about 6:36 in New York City, so the sun is a little bit crazy, so only keep it on for a second. But just let you know that it's actually sunny in New York for those of you that are not in New York. When you join us in May, it'll be great weather. I promise. It's been pretty erratic the past couple weeks, so I'll turn my camera off now. But I just wanted to show you the kind of like the sunshine coming in, that it's actually happening. It's officially spring in New York. So at this point, I'd like to just move on to what our agenda is for this evening. When I say this evening, I'm in New York, so that's the time zone I'm referring to. But for those of you in different time zones, whatever time of day it is for you, want to make sure that you are successfully developing your skills and knowledge in R. We saw during our first online session that we're pretty dispersed, right? Like disproportionately, there's a number of people that are pretty new to R. And so that's why this first bullet point exists. Secondly, I want to make sure that you have an opportunity to practice. You may have mastered like chapters 3 and 4 in the R Fundamentals book that I put together for you, but it's always great to review. So I want you to have like patience in this learning process. And so if you've already kind of covered some of these things on your own, that's terrific. You can only benefit by having more reinforcement of the concepts and also having some diverse examples and seeing from your student colleagues how they're solving problems differently than maybe you have. And I mention that because in the text chat, as we go through, today we're going through exercise 3.1. And if we have time, a little bit of 4.1. Want to see how you solve some of these questions as well. So I'm going to ask you to post your answers in the text chat. And then finally, to have an opportunity to answer your questions. Okay. So we're going to start with just like the agenda of the topics for what we're going to be discussing today. So it's just 3 things. First, I want you to really understand the concept of packages and what they are and how we use them. Secondly, I want you to feel really confident importing data and then being able to like interrogate that data that you've imported and thinking about that data that you've imported into R as an object that then you can manipulate and transform and be able to query, okay, or ask questions of. That's really the key objective of being able to bring data into a programming environment like RStudio. And then finally, I want to make sure that you are comfortable writing code like in advance of executing it. So the idea here is that you plan your code in advance using R scripts, and then you're able to see where you make mistakes in any of your coding and receive feedback from the compiler, but also as you're writing the code as an R script. There's a few signals there for feedback. So it looks like we have a great group tonight. I'm seeing 30 plus attendees, so awesome. Thank you for attending. This is about almost half of the MSBA class. So this is fantastic. So obviously this time works well for a lot of people. Great. So let's talk about the first topic. So packages. So what's a package? Does anybody have a good definition of what a package is? If you do, like, you could shout it out or just type it in the text chat. Okay, so for 30 people, there shouldn't be radio silence. Okay, good. I'm seeing some stuff now. All right. So Michelle, Kristen, Ali, Sojana, Maria, a lot of you, and some people that just went by so fast that I couldn't even call them out. Jayanta, Kurt, Yogesh, Maria. Good. And like when I give you these prompts, I really want you to think about them. So even if you're responding like a little later than like the first person who responded, who cares? The idea is that I want you personally, not the class, thinking about the questions that I pose. So what's a package? And we use them a lot as our major toolkits in R. And so a package contains a set of functions that allow us to manipulate or operate on a object or a set of objects. So that's how we would say it in like computer science speak. So a package, here's the simple way, is a folder that contains a set of functions that then we can use as long as we have access to that folder. And to have access to that folder, we need to kind of install it to make sure it's part of our R environment. Okay? So that's another way to kind of think of a package. And I mentioned in the first session, when we think of functions, like for instance, we talked about the round function. That's a function. Okay? Square root, that's a function. Read.csv, that's a function. I'm typing these things in the text chat. These are all examples of functions. These come from diverse packages in R, okay? So it's really important for you to know the association of the function and where it kind of comes from, okay? And if you know what it comes from, what the package is, then you'll have a good sense of what type of object it will you can manipulate with the functions of a said given package. So this is really abstract, but I want you to have a sense of the ways that we can manipulate data and other elements or objects in R. And we do that mostly through the use of functions. So if we think about how we install packages, let's look at our RStudio screen. And if you look at the lower right-hand side of your RStudio screen, which is like the default view, there's a tab called Packages. And so if you have RStudio launched now, that's awesome. Like if not, you should probably just do that so you can kind of look at it in your own environment. But if you're just looking at mine, I'm showing you like a zoomed in view of the Packages tab within RStudio. Here you can see a list of the packages that are available. So my question to you is, what does it mean when there's a check mark next to these different package names like ggplot2 or graphics? So somebody said, is this installed? That it's a library assigned, that they're enabled, installed, enabled, packages usable, loaded. So you see there's not like a single unifying response from like the class, right? So it's like, well, is it enabled? Is it installed? Is it available? Okay. So why don't we clarify that? When you go to the Packages tab in RStudio, anything that you see that's in like a hyperlink, like extra font, foreign, ggplot, these are all packages that are installed in your instance of R. Okay, so you do not have to install them. However, when there's a nice little check mark next to them, that means that they are available for you to use as you see fit as you're programming in R. So if I needed to use something from the GG themes package that I'm mousing over right now, You notice it's not checked. So in order to do that, I would need to check this box in order to use some methods that are available or functions from the GG Themes package. Okay, that's all that means. Now, instead of looking at this list, what's the, if I was to write code that would show me the list of all installed packages in my instance of R, what would be the command that I would type? I have some capital L libraries. Let's have libraries without parentheses. And now I'm getting like some consensus on library with parentheses, right? So if we look at just what Jared wrote and many others, lowercase l for library, open, close paren, no parameter, that would return the list of installed packages that you have in your instance of R on your laptop or desktop. Good. So let's say that you see that, but you want to use some function from the GG Themes package. How would you enable the GG Themes package? There's two ways. We kind of talked about one of those ways. This is awesome. I love the response. Like, please keep up this participation. This is great. It's great because, again, like I said, there's not one way to do things. And I want you, because many of you made the point to me that you're new to learning R, you're new to coding. So you need to talk about specifically what you're doing, and to do that like in English first, and then we talk about how the syntax to do that. So first, we want to enable the GG Themes package. We would check this box. That's one way to do it. We don't need to install anything. Anything in this list, or when I type library, open paren, close paren, installed already. Don't have to worry about it. However, I want to use the functions that the GG Themes package gives me. Absolutely need to make sure this checkbox is checked. Now, if I'm writing a lot of code, let's give you that scenario, and I don't want to kind of like intervene and start like checking packages or checking to make sure, you know, the right packages are checked. How do I know that they're going to be checked? You never really know. So in our code, we'd always say library GG Themes before we use the GG Themes function. So that just ensures that, hey, I'm enabling this library, and now I'm going to use a function from the GG Themes package. It might be, this might be my function, theme underscore Tufty, or theme underscore, and I'll explain what these mean once you get to my data viz course. But these are functions from the GG Themes package that allow me to do something pretty amazing. Take any data graphic I create, so a bar chart, a scatter plot, and apply a theme that makes my graph look like it was published in The Economist or the Wall Street Journal, or under the tutelage of Edward Tufte, who's considered the grandfather of data graphics, or make it look like it was produced in Google, even though it was done in R. But you can have, it allows for like a style to be applied to your graphics. So that's what the GG Themes package does. And these functions that I just kind of mentioned are ones that we use to apply those different themes. Okay, so that's the big long story of like functions and how we work with them, and how we need to ensure that we enable package in order to use the functions that we want. Okay, let me know if there are questions on this piece. Second point that I want to make is that if there's a package in your list here that you want to use, that if there's a package that you want to use that's not in your list, then we use the install packages. So many of you have installed the psych package, for instance. Many of you might not even have this GG Themes package installed in your instance of R. So you might want to install that because perhaps I inspired you to think about the possibilities with R and formatting of data graphics, for instance. Or you might not even have ggplot2. Okay, that might not have come pre-installed with your version of R. So if you wanted to install them, you click Install Packages, you'd search, and then you'd enter the package name, ggplot2 or GG Themes, whatever it was, that didn't appear in your list, right? It has to be something that's not in your list. That's when you use Install Package. And then you install it, and then you'd see it appear in your list of packages, and then you would enable it by either checking the box or saying library and passing in the name of the package that you want to make sure you have access to. Okay? Good. Okay, let me know if there's questions. Yes, Ali, you can install a package on the fly while you're writing code, but you don't know the like unanticipated consequences. So it's good to kind of like sequence that out. Good question. Marlene asks, how often are new packages created? Great. Well, Marlene, like if I was a single production house responsible for R, like say a tech firm responsible for R, on my team, I might have many developers developing packages, but I would probably have like, a marketing team to promote the new packages that were coming out, and then let my audience know in advance that there are new packages coming out and what the capabilities are. Things are not so organized in the world of open source, as you can imagine. So R is an open source platform and programming environment. This means that not only can people who are paid to develop packages contribute, but people that just want to contribute packages, like our very own Louis Torgo, who's going to be teaching a course of yours, he has his own R package that you guys are going to use for machine learning and data mining. Like, how cool is that? And guess what? You can even create your own package. Okay, so you can create a package, which essentially is a folder that contains functions or function definitions that allow you to manipulate objects in a special way. If you wanted to create a set of functions that just took every word that you passed in as a variable and add the letter D to it, that could be a package, a special package. It could be the D package. So there are, thousands of packages in R, and each one has an author. And so that's where you see this collaborative environment. And that's why there's a base R, which is a set of base packages and functions that are available. And then there's all these extensions that we use a lot. And that's what's really propelled this programming environment R and RStudio into this area of machine learning and business analytics because of its extensibility, and that there are so many experts in, say, machine learning and data science that can contribute. And us as coders and business analytics professionals can take advantage of that. So Maria, sorry, that was a really long explanation, but I hope that was helpful. And Marlene, I'm sorry, Marlene's question, then Maria asked, why not have all the packages already installed and available? Good, because our working memory is pretty limited on our computer. So if let's say you're working in R and you open up Excel and you open up PowerPoint and then you open up a web browser and then you open up Photoshop and then you go to training and then you open up, another application, like maybe like a social media platform or a chat or your photos or a video editing software package. it's going to get a little much, right? Things are going to be running a little bit slower because you're using a lot of RAM to hold a lot of information in memory. And while computers are faster and faster and exceeding Moore's law these days, they're still pretty limited. So we want to conserve our memory for the things that we want to do, and we want to make sure that the actions that we take, which are the methods or the functions that we use, go pretty quick. So for instance, if we're loading like a pretty big data set, like say like 10,000 rows, like that's going to take a little bit of time to like import. And then if we do a computation on it, that might take a little time. I mean, like maybe a second. However, compound that by other functions and having other applications open. So Michael asked, are they all open source or such thing as a proprietary package? Everything that I've used has been open source. I don't know, there might be some proprietary packages, like for instance, what a lot of companies have tried to do around R, including RStudio, is actually the publishing platforms tend to be proprietary. So if you create an interactive application in R, and probably you did it in RStudio, if you want to actually publish that on the web and make it work for for everybody in the planet, you would probably need R server, which would be a server, obviously, that you would need to make sure that you had an account on and you would have to pay for. So obviously there's academic versions of all of this, but that's really how developers have capitalized on providing open packages like RStudio and open applications and capitalized on it. So Jonna asked, also functions might overlap between packages and would be a problem if all packages were checked. Yes, that's true. So sometimes there might be a package called a function called like summary, and it's used in like 3 packages. And so which one are you referring to could also be an issue. It's a very, very good point. All right, good questions. Thanks. So this is just a summary of what I kind of said. So I don't believe in kind of reading text off the slide, so you can read this yourself. Or when you go back to the recording, you can take the time to read this, but it's basically saying the same things that I just said through my demonstration. So now we're on our second topic, and I see Kurt has a question. So before we go into importing data, I want to address Kurt's question. Would we deactivate by simply using the library ggplot2 again, or is it required to switch to another package? So if what you do is you would uncheck. You can uncheck the package. That could be one way that you could make sure that you're not using it. Usually, when you have an instance of R, it's very rare for 2 functions to be named the same thing. Okay, there are cases, and I believe it actually is with like a simple function like summary that that is available in a couple different packages. And packages get deprecated, so you might be using one, in 2018, and let's say you don't apply some of the skills that you learn until like maybe the end of the program, or let's say you do a big career switch, and now in 2020 you want to start using R to do some interesting things for the new company, organization, the startup that you started. You might notice that some of the things that you did in the past have been deprecated or haven't been updated in a while. And so you're using like a 2018 version of it, and now there's a better package available created by the community. And so these things happen a lot, so something to just be aware of. This happens in Python as well as many other kind of programming environments. Okay, so importing data. I know we did a little bit of this in our first session, but I like to go over how to do this, and I know there were some questions on this, and so sorry, it might have been Jared or someone earlier who asked some questions about how to make sure we import our data, and maybe our studio doesn't give us some of the options to import data through like a GUI interface by saying just like there's a button that says import data, and then we see the drop down and it says, import CSV. So I want to show you the code way of doing it as well. So there's two functions for importing data in R. One is called, for importing CSV files in R. One is called read.csv and read_CSV is the second one. Does anybody know the difference between the two? Two different functions. They look really similar. Ali, that's a good answer. Ali says no, but I've had instances where one of them did not work in my script. Okay. So things not working is part of programming. And believe it or not, like most of the time, it's your fault, but not all the time. Okay. So when things don't work, it means that maybe like you had a typo, or that data object doesn't exist that you thought it existed, or you're just, using a wrong character. And other times it's like, oh, wow, there's a parameter missing. And then when it's not your fault is usually when you're using a package that's deprecated or your instructor made a mistake. But all those times are really rare, right? Mostly when you're in the process of like learning something new, there's going to be mistakes, and that's what's so amazing, and that's what I love about teaching programming is that you've got a lot of feedback. You get feedback not just at the end of the assignment, but as you're coding, when something doesn't work, immediately. And then it's trying to find, you're always in the situation of problem solving. And so going back to the tutorials and asking questions here is the best way. So I see some different answers, and these are great. I appreciate you trying to answer the question. So if we talk about read.csv as a function, this comes from a library called utils. Okay, we just talked about libraries. It's from the utils library. This is like standard. It's always installed. The read_CSV function comes from a library called readr. This library you typically have to install, and when you installed RStudio, it might have been installed for you already. But it comes from the readr library, which is also bundled with a library called tidyverse. So it comes in like two different forms, but it's the same set of functions. Okay, so read.csv is a function. It comes from the utils package. Read_CSV, a function to read in comma separated values. That's what CSV means. That comes from the readr package. Okay, and when we use the function read.csv, we're creating an object. Okay, and that object is imported as what we call a data frame, which is a data structure. Okay, so I've introduced you to variables, and I've introduced you to data structures. Okay, and now I'm introducing you to something called objects. And so objects also have types, and objects are the thing that we're able to manipulate with the functions that we use. And so an R object, let's call it an R data object, is certainly a data structure that is a form of a data frame. So that's where some complexity comes into play. But like object is a very generic term for any kind of instantiation of, let's say, some data as just an example. So let's say import data set Winter Olympics CSV, right? And I call it winter. Winter is an object. I import another data set called March Madness, and I call it March. March becomes an object. So now I have two objects I'm working with. And those objects are actually data frames that can be manipulated using functions that allow me to manipulate data frames. Some of those functions could be something simple like the dim function. You might have used this already for me to get the dimensions of the data frame. Okay, so a data frame is a data structure, and a data structure is an object. So we have something that's like, it's similar to what we call inheritance. And if we ever want to know really what the thing is that we're looking at, like let's say winter or March, which are our data frames, our objects, we use the class function, and the class function will return the type of data structure we're working with, if we're working with a data structure at all. Okay, so that's a little bit about read.csv, and also understanding that anytime we use that function, we're getting a data frame. Okay, we're getting an object that's a data frame. Anytime we use read_CSV, we're getting an R object as well, and it's an R object that's a tibble, which is also known as a data frame, but it's a simpler data frame. So let's say that data frame was like, oh, data frame is 2016, tibble is so 2018. Okay, it's like the new way of branding, for lack of a better term, the data that you import in R. And it has some advantages. So when you use the read_CSV function, it reads in our data, and it doesn't coerce it. And that word coerce really means doesn't transform our data that, for instance, is of type character into data that's of type factor. And that's really important that some of those corrections have been made. And so instead of correcting the read.csv function from the library utils, because somebody else wrote that, we have a new function that was written by, Hadley Wickham and a few other people called read_CSV that lets us import our objects in a kind of tidier way, or just a neater way, and a more modern way. So it's called a simple and modern data frame. And so I just want you to understand that a tibble and a data frame are pretty much the same, but they're not exactly the same. So let's say you have a function that only works on data frames. It doesn't work on tibbles. Then you need to convert any tibble that you have to a data frame, which is very easy. But that might be we might be getting, too far ahead of ourselves. So are there any questions between kind of the difference between these two functions? Okay. So if we look at an example, nothing that surprising here. But on the left-hand side, we can see we're using the read.csv function. We're reading in some data in parentheses called winter_olympics.csv. And we're saying, hey, this data needs to be, this data is, the delimiter in this data is a comma. And what do I mean by delimiter? Is that a term that you guys are familiar with? Separators between the data. Yeah. So like you've been working with the Winter Olympics.csv data already. And if you tried to open that data in like a text editor, not like Excel, you would see that it was every element in that data set would be separated by a comma. Sometimes they're separated by tabs. Okay, sometimes they might be separated by some other special character. When a file is named .csv, it means that that there are comma separated values. A TSV file would be tab separated values. An XLSX would mean that it's an Excel file and that we don't choose the separator at all. We use a different function altogether. But I just like to kind of point that out. And then the next parameter that this takes is header equals true. What do you think that means? First row is the header. Fantastic. Our first row in our winterolympics.csv file that we're trying to import represents the column names or our variable names. Okay? So really important to make sure you specify that. So if you were to import data by hand in R, this would be the code that you would write. Okay? Using the read.csv function. One question though, what does it imply when I have in double quotes winter_olympic.csv? Where is R looking for my data? So again, I want to remind you to, if you're not, you should be looking actively at the text chat as you're looking at this presentation, because the class is really contributing to the prompts that I ask. And I said, where is this file? And great answers. And so somebody says, like, it's the working directory, the active folder, the default working directory. And those are great answers, right? So the assumption is that whatever my working directory is, meaning R knows where to look for my files because I told them to, or I told the program to, or I told R to, and I can tell them using a certain function called set working directory. I just wrote that out. Okay, set WD open paren close paren, and then as a parameter there, it's not just I actually enter some values in there. I would give a path. Okay, that would be my working directory path. Once I do that, this code here is super easy because I just say get that file that's in my directory and import it. Okay, and then assign it to an object called data. Ollie, great question. Okay, so Ollie says, every time I start, RStudio, I have to reset my working directory, and this is where you can start, creating a project. So if you say new, like file new R project, you can set an R project. It will ask you for a directory, and you can give that project a name. And so you can call it like, fundamentals of statistics using R, or figure out some abbreviation of that. And then when you take Louis Torgo's class, you might have another working directory that you'll put all your files in, another project you'll create. Okay, so I'll demo that. That's a great question, Ali. Thanks. And you can also do, Kurt says, under tools and options. So we'll look at both of those when I do a demo. Good. So I just want you to understand what the left-hand side of the screen means. And then the right-hand side of the screen, it says read_CSV, and it's passing in winter_olympics.csv, no other parameters. That's because read_CSV is so smart. It already knows it's comma delimited and that there's headers set as true. And those are default parameters for read_CSV. And then we can assign that to an object called data. So we like to be more contemporary in some of the functions that we use. So we're going to use read_CSV anytime we import data that's of type CSV. So what does that mean? It means that I just want you to recognize that there are two different functions that exist for reading in data, and the one that I'm going to ask you to use throughout at least this course. That's much more productive. In addition, I'm going to mention that the read.csv is a convention in R. I mean, it's not a convention, I should say. It's been a way of importing data for a very long time. And so there's a lot of documentation that will show you how to do something. But in the process of showing you how to achieve a particular task, it will have a function of like reading in data first, and you'll notice the read.csv. And I don't want you to be confused. I want you to be clear that like, okay, that's just like reading in the data, okay? So again, let me know if there's questions on that. Our third topic for today has to do with R scripts. Great, thank you. So R scripts are particularly powerful tools for us as coders. And why are they powerful? Does anybody have any like intuition about that or response? Great. There's a lot of answers to that question, and all of the ones that you wrote are true. So one, you can save your work. So now we're not writing at the console window. We have a script that we can plan out our code. We don't have to write it in all one chunk. We could take some time to write our code and save our work. And then once we get something working that's really effective for us, like let's just say the basics. Let's say that you wrote a program that first imports like the relevant libraries, second sets your working directory, and third imports a data set. Well, you might want to reuse like those like 4 to 5 lines of code every time. So you can just like cut and paste from script to script. There's other things that you can do that are even more efficient, but that's like on a simple level, you can certainly do that. And it also allows you to document your work. So as you write those lines of code, you can kind of tell yourself in English that, hey, this, like above every line of code, you could say, this imports the data, this, runs some summary statistics of the data, this line subsets my data, and this line provides me with the answer to this particular question. So that's really helpful. And then when you do that, if you're saving your work, if you're finding your work valuable for yourself, like reusing your code, and you're taking the time to document it, chances are other people would want to kind of see that. So you can share your work with others. And so obviously for like capstone projects and any kind of collaborative projects, you're going to want to share your work. So R allows you to do that. And it's not only R scripts. So you can take an R script and you can publish it to the web, like in a couple steps, using a library called knitr. I'll write that down in the text chat. I always like to write the libraries down because you might not be hearing the letters that I'm saying like quite specifically, because knitr isn't a word that you're used to probably hearing because it's a special name for a package. So it's called knitr. And so that package is amazing. It allows you to publish your work as HTML or as a PDF document or as a Word document. Got lots of options there for sharing and also publishing your work into different formats. And then you can also, like the last point is that being able to go beyond writing one line of code at a time. Great. So Riza says, well, that's great if I share my scripts, but it's looking for data that's in my working directory. So of course, but let's say that we were working with data that was on a database and we're both pointing to the same file. Okay, so we'd be having a different kind of function to read in data, but all the other stuff would stay the same. Okay. And so when you shared that, you both be pointing to the same data set. When it's in your working directory, you'd also have to share the data with your colleague. Great question. So we're getting to the point where I'm going to ask you to open RStudio and make sure that you have access to exercise 3.1. And again, the direct link to exercise 3.1 is in the materials tab in your GoToMeeting, or I'm sorry, excuse me, go to training session. So you can just click there and then it directly takes you to exercise 3.1. So we're going to work on this together. Good. And we're going to start by opening up RStudio and creating a new R script. Okay, so in this exercise 3.1, we're going to not only focus on some of the principles that we learned today about packages, about importing data and R scripts, but also how to manipulate our data, for instance, subsetting it. So now importing a whole data set and then taking a little portion of that to work with. And again, we do that a lot for memory reasons and also just because we want to be working with a simpler set of variables. Right. So like, for instance, like I have a very good colleague that works at the Federal Reserve Bank of New York. And she's like, I'm working with 600 variables. And when that can be proved very difficult if really the variables of interest are only 5. So why not just work with take a subset from the 600 and look at 5 in particular. So we're going to be importing a CSV file, learning about our data, creating an R script, and then creating subsets. This is a preview of what exercise 3.1 looks like. So again, you should have access to this. And we're going to be using the march_madness.csv file. Please make sure you download this file into whatever is going to be your working directory. Okay. And if you're ready to go, I don't think you can give me a thumbs up, but maybe you can just give me a yes or a Y in the text chat. Woohoo! I like that. That's great. All right. This is great. So I have a lot of things open in my R environment. And I always like to keep it that way when I do these sessions, just so you kind of know how I restart. So anytime I have something that's a bunch of stuff going on here, I was teaching some undergrads some R code this week. I press Control L and I clear my console window. So that's all clear. And then I'm going to create my new R script, new file R script. That's where we're starting. So no, you can't do that, Abhijit, because first, that's not the file that we're working with. That's where the data came from. And you're not referencing a CSV file. You're just referencing a directory. So you need to reference the file itself. And so if you can find the updated file, that's great. So you could do that. You can go directly to a URL. I like to make sure everybody has consistent experience. So please just download the data set that I mentioned, which is a little further down in exercise 3.1, and then just import it. And then we're going to import it kind of we're going to go through a little bit of slow process here. So Abhijit made a really good point. He's like, hey, can I just import this directly from the source, from the URL? And we can always import data directly from a website if we want to, if we're allowed access to actually, download data. And many websites allow us to do that and give us a direct link to the CSV file. In the March Madness case, I'm giving you a data file already, and I was just giving a URL to tell you where that came from. Jayanta, I'm not clear on your question. Can we just use download function for such app? Yeah, I think we might be just getting ahead of ourselves. It depends if if we're going to download the function, um, we can certainly download data and then store it in our working directory. We can reference that data. We can reference data live, or we can reference it when it's in our working directory. So all those things are possible. Okay, so like what we're doing today is we're assuming that we have our file where it needs to be, and then we're going to work with it there. Okay, so to do that, let's just, we're going to do a few things. So first, many of you may not know yet where your working directory is. And so we're going to go ahead and use the interface of RStudio to set our working directory. And then when we do that, we're going to see code that appears in our console window that are actually the functions that the setwd function that shows us what our working directory is. So let me just show you what I mean. So if we go to session, set working directory, and then choose the directory where your data files are stored. That's what I want you to do now. Once you do that, whatever directory it is on your desktop, just choose it. I'm going to choose this R fundamentals one, and I'll say open. When I do that, I get this command was executed, set working directory, double quotes, tilde, and /Dropbox /R_fundamentals. So that's my working directory. Okay. So as one of my first lines of code, I'm going to make sure that that's included. Anytime I run this script, I want to make sure that it's looking in my working directory for anything. So again, we've started by saying like file new R script, and then we went ahead and set our working directory. We did it kind of manually by going session, set working directory, and we chose a directory. After we did that, the output was the code that was executed. I cut and paste that code and I put it in my R script so I can save it for later. And what I'm going to do in my R script is the first thing you should do is write your name on it. And this is exercise 3.1. Gives yourself some notes so you know what you're working on. And then some space, and I'm going to say what is actually happening on line 5, set working directory. So the #, these are comments that allow us to write notes to ourselves within our script. And once I have this much done, let's go ahead and save our R script and say file, save, and then it takes us directly to our working directory. So now that we set it, like everything's going to be pointed to that working directory. So I'm going to save this as exercise 003 new, because I have many of them. So there it is, exercise 03 new .r. I didn't have to add that extension. All R scripts have a .r extension. So let me know if you're good with me so far, or if I'm going too slow, too fast. Fantastic. All right. And you can send me a private chat because I understand if you're going too fast or too slow. You might not want to say that in a public setting. You should feel comfortable doing that, but if not, I totally get it. So just send me a private chat to let me know. Great. So then after we do that, our next step is, right, this was question 1 in exercise 3.1, set our working directory. And question 2 is asking us to import our CSV file. Okay, so go ahead and write your code to import the CSV file, and then I'll get to it in a second. And remember, when you save your R script, and you just do that by saying File, Save, and it takes you right to your working directory to save it, and then you have the option to give it a name. So Jana, just make sure that you're going to the CSV link that I showed you, not to the NCAA link, but to the one that's like on my Becoming Visual. Click on the link, right click on the link, and then say download. So I'm just adding a new tab in my browser. So if we're in R fundamentals, so you guys know that this is your source for like everything R in this course. We're working on exercise 3.1. And if you want to import the CSV file, I need you to click on this and then say save link as. It will prompt March Madness, and you'll see the format is comma separated. And then you can go ahead and save that. That's how you download the file. Okay, so if you're having any issues with that, that's how you do it. I hope that was just a helpful demo on that. Once you've done that, make sure wherever you downloaded that file, it's like also in your working directory, whatever that you set that as. Mine is R fundamentals. Okay, so that's where my March Madness file is. If I want to import my data, there's two ways. So let's do it the graphical way. Great, Riza. Fantastic. The graphical way. I'm going to show you how to do it two ways. You go to import dataset from RStudio and you choose from text read R. And then you get a dialog box that says import text data. We browse. We look in our directory, and here I'm importing marchmadness.csv. I open that up. I'm going to go ahead and rename that to March. And you see the default options, first row as names. That means our first row in our data preview shows column names or variable names. And we keep everything else the same. So Jayant, I want you to use underscore CSV, not dot CSV. Yeah, okay. And then we get a code preview. And it's requiring our library read R, it's importing our data, and assigning it to a data object. So now I'm going to say import. So we see that it's done a few things. It's imported our data, and it actually launched this command called view March. But let's scroll up a little bit. Excuse me. Let's scroll up a little bit. This is the command that we use, that it was executed RStudio executed for us when we said import dataset. It executed read underscore CSV, passed in March Madness in double quotes, okay, using the default parameters, and assigned it to a data frame called March. We're going to go ahead and copy that, and we're going to return back to our R script, which I called mine exercise 3 new. And I'm going to paste that on line 8. Why am I doing that? Because I want to show you both ways to do it. I've got a lot of questions in the discussion forum that, oh, I'm getting an error, like R can't find my data object. I named it March, or I named it Winter Olympics, and it could be because you did not write it in your R script. You just imported it by hand. And you did that 2 days ago. And you're expecting R to remember that that object existed after you restarted R and nothing was saved. So when we're writing a program, we do everything programmatically. So when we do an R script, we're writing a program sequentially. First, we set our working directory. Second, we import our data set. If you've used any of the graphic functions, you're kind of interfering with this step-by-step process. That means that now your script relies on you to like make sure the data is imported and make sure the working directory is set. So I like to include it in the script itself. Good. So Marlene says, do we need to require the library readr? And we probably should. So let's go ahead and make sure that readr is enabled. Great point. Okay, so now we've answered questions 1 and 2. And no longer do we have can we use RStudio to give us, to help us with the rest of the questions. The rest we will be having to write code to answer the question. So let's go number 3. We can view our data. And viewing our data can take many forms. We can write a function called view March to view our data. When we execute this function, it launches a different window in RStudio. Wonderful. We can see our data looks like it's in Excel, which is wonderful. However, this is great for a preview, but typically in our R scripts, we don't want to have this particular function is a special function only available in RStudio. And we typically don't want to use it when we're running a bunch of lines of code at once. One by one, it's fine, but when we run a whole script at one time, we don't want to use the view function. Instead, we'll say something like just March. Typing the word March will just print out a preview of our data frame in the console window. That's kind of good enough. It does the same thing, but it does it in our console window. So what I did in front of view is I just put a comment in front of it, which means that this code won't run. Yogesh, you're saying for me, R converts read underscore feed to, we'll just make sure that you write it read underscore CSV instead of the other way. Don't let it convert it. And you might not have the readr library installed, so make sure you have that library installed and enabled. So we go on to question 4. It says print the number of rows. So how would I print the number of rows for my data frame? I mean for March Madness. Great. So dim March, is the minimalistic way to write it. We could say print dim March, but this is the solution. And in my R script, I can highlight line 16 and I can say run, and that will just run that line of code. Okay? And so writing code in a script format allows me to write code and then execute one line at a time at my own pace. So let's say I said dim M-A-R-C, dim mark, and I ran that line. Oh my gosh, object mark not found. Obviously, I made a typo. However, R is saying, hey, that object doesn't exist. I can't use the dim function on an object doesn't exist. I need an object. And then so I could correct it and run it again. At this point, I have pretty strong confidence that lines 1 through 16 are written perfectly for my needs. They're giving me the output that I want. So now I can continue. And if I get another error, I can kind of assume that it was probably from the last line of code if I do this step-by-step approach, okay? So we're both, like creators and executors at the same time. So let's move on to question 5. How would I print the column names? So fantastic, we can use a function called names. Okay, and then we can pass in our data, our tibble, March. And what that's gonna do, I want you to pay close attention. When I press run, that's gonna print the column names for how many columns? Can anybody tell me real quick? How many columns? 9. And you can tell because when I get my output, it's showing me that on line, the 9th element, non-DI, that's it, right? So that's showing me that I have 9 column names. If there was another element right after non-DI in this row, then we would assume a 10, and then 11 or 12. And if it went on a different line, then it would be 13. Okay, good. So now I want you to change the column names to lowercase. And once you've done that, share your code. I'm going to give everybody like a minute to do this one, just so you can think it through a little bit. Seeing a lot of correct responses. So right now I'm working on line 21. I know everything above this works. I'm going to re-execute line 19. I highlight it and I press the run button. That's giving me all my column names we already discussed. There's 9. I want to change those to lowercase. So I cut and paste this names, right? Because this is the vector I want to change. Whatever is returned from this function. Okay? And I'm going to pass that vector in to what? To a function called toLower. Because I know that function toLower will convert whatever I pass into it to lowercase. And let me just go to the console window. So follow my cursor. I'm in the console window now. If I say toLower and I say the word, let's say it's my first name. Okay. Maybe I'll use my last name so then you learn how to pronounce it. I know it's harder. Sosulski, right? And if I want to change that to lowercase, I pass in this string and I use the function toLower and I get returned my last name in lowercase, Sosulski. Okay. I want to do the same thing here, but then I want to reassign it so it gets saved. Right now, what just happened, say toLower with Sosulski and Sosulski didn't get saved. If I run this line 22, yeah, it turns everything to lowercase, but I didn't save it. And so what you see from some things that your colleagues have done, they've actually taken this function within a function. So I'm using the names function, this vector, which we know contains this data right now that will be converted to like this data, or these data, I should say. And it'll be, so it's lowercase. Now I want to assign that to what? To the vector names March. That might not be as obvious, but that vector that I'm referencing is, that first row, which is actually known as row 0. Okay. Let's do that. So let's run this line of code. So I have an error because what's my error? I have a typo. Most things are typos in programming. That's why, like, some of you wrote in the discussion forum and I responded to you in like 3 seconds, because you can see these things once you like start debugging like so often. Okay, so now I got it right, but how do I prove I got it right? Well, now I can type in names March in my, I'm going to do it in my script so then it's repeatable. And then I see that everything's changed. Voila. Good catch, Christopher, on the S. I always think the most frustrating thing to do is watch somebody write code because like they'll start making typos as they're writing. I like to do this stuff live with you guys. And then when we do stuff in class, I have a lot of it done and we follow along and we explain it because it takes too long. But this I want you to really follow along with and think before you see the results. Good. So now the next question, number 7, and we still have plenty of time to get through this. Explore the variable type. So I say that use the str function. So variable types. So how would I do that? How would I use the str function? Yeah. Again, if you're not sure if you're like str, what's that? At the command prompt, just type $str, and you'll see in the help file on the right-hand side, it says compactly display the structure of an arbitrary R object. Now you know that data frames and data structures are R objects. And so it will give me information about, let's just do str March. It will give me information about my March Madness data set. Excuse me. That you can go ahead and take a look at. It will tell me the number of variables that I have. And I have to make the screen bigger and kind of scroll to show you everything that it shows, but you try it on your screen. But it shows a list, obviously, of 9 variables. All right, so now I have some content questions for you. So up until this point, we've really just been like getting our data in, making sure that we're set to do some coding. Now I want you to, in question 8, do something where you're going to answer a question. So I need the code and I need the answer. So how many different conferences are there? So I'm going to say Ali and Maria, how did you get 33? I saw this one. This is by Gianta. So let's look at this one. Wait for some more to come in. Gianta's adding a function within a function. She's saying length unique. Gianta, I like that answer better. It's great. So one way, there's a couple ways. I see people using factor variables and other things, and that's terrific, and that's where I really want you to be headed for. So one is good. Is I'm gonna show you a long way, and so Jance's way is like very elegant. So first, we're only looking at this column, March conference, right? This shows me all the conferences. And if I just look at this quickly, let's just run this line of code. We see that there's 349 observations. right? But not 349 conferences, because you see that Southern and Southern, for instance, are repeated. So we want to look for unique conferences. So the next step could be line 30. Use the unique function to show me those unique conferences, meaning that they're not only the ones that aren't repeated. So I wouldn't show Southern twice. I just show Southern once, for instance. Okay, and so then it just gives me a vector of 33 conferences, right? And we can see that by showing the output of 33. That gets me close, but doesn't get me that close because I want the number. I don't want to have to look at the output and then interpret it. I want the number. So then we can add the length function here. Okay, and I'm going to say run, and then I get the length of that vector. How cool is that? Okay, I get the length of the vector March conference when I use the unique function, which we knew already was 33. So this is one approach, okay? So I'm going to say approach one. This is fantastic. Now, many of you also talked about using factor variables. So I would like to kind of go through that, that approach too. So we could say something like, go back to our March conference vector. I'm on line 34 now. So I'm going to say this is approach 2. So stay with me. March conference. Okay. And then what I'm going to do, I'm going to reassign that variable, March conference, as a factor variable. Okay, so let's run this line of code. Now, line 36, let's run that. Let's look at what we did. We just converted the data type. March conference originally was a character, okay, and you could check that out. So now this tells me I have 33 levels. So what it did is it assigned a unique number to each type of conference. And we know that there can be more than one type of conference. Okay, so Southern, let's say, would have the same on this observation would have the same number as this observation. Okay, just like they have the same word Southern, there'd be a number associated that would be the same as well. So then, using factor variables, we can deduce 33 levels. So we know that that's the right answer. Again, it's not giving us just 33 as the answer. Okay, so we need to do one more step. So I just want to show you how both approach 1 and 2 are going to be about similar number of steps. So approach number 3 uses something called n levels as a function. And guess what that tells me? It tells me the number of levels that are available as my factor variable. So then I'm going to pass in, of course, March conference. Okay? And then if I run that, voila, 33. So both approaches are fabulous for determining this particular, answering this particular question. Marlene, you're right. If you did that, you'd already have you'd have March conference as a factor variable, so you'd only have to do this line of code, line 37. We want just the output to be one number. We don't want it to be, we don't want to use str. We just want one number. Even though printing out even the data on line 36 gives us the 33, but this n levels gives us just the number 33. Then I could assign this, let's say, to a variable x. Okay, let's do that. And then print out x. So run. We know x is 33. We can check the class of x, and we see it's an integer. Okay, so now I can store that as a variable, as a single number. With str, we're not just getting a single number, we're getting other data that comes with that as returned from that function. Cool. All right. So our last question I want you to work on. We're going to finish it out 5 minutes. So 2 parts. Let's look at the difference in the values between the first 2 columns. What are the first 2 columns? Rank and previous. I want you to tell me the difference between rank and previous. So when I say difference, obviously I'm talking about subtraction. I need you to subtract these columns from each other and tell me the difference. Okay, so you're gonna create a vector called diff and calculate the difference. Then part B says print count and list the schools that have changed 3 or more places from rank and previous, okay? Or from previous to rank. So when you've done that, cut and paste your code in there, and then I'm gonna do a demonstration of that. So we're doing 9A. I'm just setting up the space in my script to work on 9A. I'm going to save that. And then I'm going to set up the space to work on 9B. Wow, you guys are quick. This is fantastic. Now, you know this is being recorded, so no worries if you're, not going as quick as everyone else. And just as a hint, in our fundamentals that I do a code walkthrough that pretty much shows you most of the solutions here, okay? So no worries if I'm going a little bit too fast. But I really hope you are keeping up. And then if you're not, you just let me know. So then I know. Not quick. Okay. Just did it last night. Okay. Thanks. These things take some thought, but let me walk you through it. So maybe you can follow my line of thinking for 9A. Okay. All I'm doing here is using subtraction. I'm subtracting one vector from another. Okay. Rank from previous. Okay. That's all I'm doing. So let's go to my demo. And so I'm gonna call this, check out what I'm doing. I'm gonna call this March $diff. Anybody know that what's gonna happen now? A lot of people are doing it, but I just want to make a point. I want to point that out. Yeah, it's going to add a column. So look how cool this is. I'm subtracting one column from another, March rank from March previous, and I'm storing the result in a new column called March difference, diff. That means if I go to my data, there's not going to be 9 columns. I'm adding a 10th column called diff. Okay, so that's how you add a column to a data object or data frame. So again, it's just taking the data frame name, $, and whatever you want to call it. You can call it pineapples. Okay? Let's just make sure my code is right. I just want to double check it. I wrote it pretty fast. And then I'm going to run this line. No output, right? Because I've added that column. So let's go ahead and take a look at March diff. Okay, I'm getting a lot of negative values, but that's showing me the difference between rank and previous. Okay. That might mean that many teams have actually gone down in rank, right? So now let me go ahead and show you my new data frame, right? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns now. Okay. So you see that I was able to add that column. All right, so most of you seem to get that piece. You're right on with that. But I really wanted to make a point that this was a strategy. I didn't have to do this, but I just added a new column to that data frame, so I could use it again if I wanted to. So perhaps I might want to use that in my next solution. So the next one is, what I like you to do is print a count and list of schools have changed 3 or more places. And I ask you to use the subset function. So I'm just going to call this like March, I don't know, subset, just so we're really clear on what the variable that we're creating it, and then we're going to subset the March Madness data tibble, okay? And we're going to say X, which is the data. That's the first parameter. My data tibble is called March. And then I'm going to say subset equals diff greater than or equal to 3. So you might have done this. What is this going to return? Yeah, like it. Good. So you guys were listening when I mentioned that you're going to need to use this again. So if I go ahead and run this with my March Madness subset, okay, that's showing me people that had only really a positive difference of 3 places. So I'm getting 3 as my output. But the question says, give me a list that changed 3 or more places. I'm not saying like gone up 3 or more places. So to deal with this, we simply use the absolute value of difference, which means that it doesn't matter if it's positive or negative. Okay, so now I can run this line of code again. So again, the beauty of writing a script is that now I can go back and I can modify. So in line 44, I run that again, and then I do March subset, and it looks like now I have 9. So you guys are awesome. Thank you. I'll stick around if you have any questions. But this ends our session tonight. And what I'm going to do for those of you kind of sticking around, if you stick around for 1 second, let me just show you something pretty cool. So I have this script, and if I wanted to, I can click on this particular notebook icon. I get a report output format as HTML. I can compile that. That's going to launch an HTML file with all the code that I just worked through with you today. Everything that we did together, okay? I'm going to go ahead and publish that on RPubs, and you can totally do this as well. You just need an account on RPubs. I have an account, Sosulski. I'm going to sign in. It takes like 3 seconds. Exercise 3, and today's date I think is April 4th, 2018. I'm going to say continue. I have a little typo there. That's okay. And right now, in the text chat, you get a URL to my code. So you can check out exactly what I did today with you. And so that's the beauty of having a script too. Now I can start publishing in many different ways, and we'll learn how to create things called markdown files and the like. But just wanted to kind of leave you with that fun little nugget, how you can actually even publish your code as well. Let me know if you have questions, and thank you so much for being an engaged audience. It really makes a difference teaching, and I loved all the alternative solutions. Very cool. Thanks. If there's any questions, you can feel free to just use your mic and ask them too, if you have it. Somebody asked about joining Friday session. Yeah, feel free. Just sign up, okay? Jared, what's your question about the file type?
Script.
What's that?
I'm trying to save the R script, and I'm not sure which file type to use. I don't have any that's defaulting, so I missed that part when you went over it.
Okay, yeah, no problem. So you're just talking about you have a script. So I'm creating a new one, let's just say, file, new, file, R script. Are you
Right.
good? So I'm typing some comments like my name, big deal. And then I want to save it, file, save as. It's going to always save as a .r file, so just save it as any name you want at this point. So
Okay, let me try that again, and I was getting an error.
okay. I'm just checking. Anyone else have questions while
Yes, so for submitting our assignment, where do I copy the data file? Like in the desktop, my data folder?
where do you copy the data file? I'm unclear of what you're asking, what the question is.
Yes. So for the assignment, if I wanted to copy the CSV file, where should I copy that? Where should my R script should read the data CSV file from?
Oh, it should read it from your working directory, right? So for instance, mine is set to my Dropbox, okay? But yours might be set to wherever your My Data folder is. And to set your working directory, session, set working directory, and then you can choose it in order to find that path. It might be your desktop, for instance.
Okay, got it.
Okay. And then the output in the console window will be actually the code that gives you the entire path, just so you didn't have to go and find it. And then you could go and modify. So let's say I'll set mine to the desktop. Okay. I'll say desktop. Now it says set working directory to desktop. I take this code and I just replace what's here. Okay. With desktop.
Okay, thank you.
Mm-hmm. Cool. Thanks, Mike. Great participation.
So Kristen, when I choose save as, it's telling me to choose encoding.
Encoding.
Yes.
So save that. Did you say save with encoding or just save as?
If I choose save or save as, it brings me to this choose encoding screen.
And what are the options there?
Like ISO-8859-1, which is the system default.
Yeah.
And then like 8 other options that are just like letters and numbers.
So just try that first one, the default one, and tell me what happens.
So I tried that one, and it brought me to the save as box.
Okay. And you're getting like a prompt to save as like exercise3.r.
So I did that, and then it tells me confirm change file type. This file was created as an R script. However, the file extension you specified will change it into another file type that will no longer open as an R script.
Good. So just type a name and don't type a dot or an extension.
Oh, I guess because I put .1.
Okay. Yeah. No dots.
.1. Got it. Okay.
Let me know how that works for you. I mean, we're going to be only working in R scripts for a little bit, and then we're going to transition to RMD files, which are called markdown files. But I want to, yeah.
The issue is I was using a period.
Okay, cool. I'm glad you got it. You're welcome. Yeah, so on your log, you're right, because if you specify X in the subset function, you're saying, hey, this is my data frame, and then I can just reference the column. It's kind of makes, you can be a little lazy then. Just checking out the other questions. On your log, does that answer kind of what I'm saying? Yeah, right. So you can be lazy. There's other ways that I've written in the tutorial that you can be a little lazier. However, I like making things kind of pretty explicit if possible. But the subset function, anytime you require the data frame within a function, you can just reference the column name then. Yeah, totally. So you can always be super literal, like saying March diff. Okay. I'm still getting my subset. Yep. Okay, well, it's 8:12. I see 4 more people online. Just want to make sure that you don't have questions. Rashad, I see you're online. Just want to check that everything's cool. You don't have any questions. I'm going to sign off. All right, then. Thanks. Cool. Thank you. Have a good night.